Earlier we spoke of, Trenton had mentioned reclamation and what the definition was. What we're going to do at this point, we're actually going to walk through that. You're going to see a little bit of how, why, where, when. You're going to see some of the equipment operate. So when you see this equipment out on the job site, you're a little bit more comfortable and a little bit more familiar with it. So I'm going to show you, we're going to walk through this video. I'm going to narrate through some of it. As you can see, it comes through a cornfield. The reason that we want that, embed that into your brain, because that really is to show this is a renewable and reusable process. This is something is green. This is a truly green process. You're taking all that material and you're pulverizing that road. Again, you're doing a full reclamation process where you're incorporating that subgrade soil, the stone, and the asphalt all in one pass. And so here you make an initial pass, and we're going to break this down later on. We're going to segment some of this, but just to get an idea, a quick overview. And what you're doing is you're pulverizing the existing roadway so you can make the corrections, the grade corrections you'd like to do. You can see the gradation. This machine is not a crushing operation. It is a sizing operation. So your size of your stone is typically going to be your particulate size of material. So he's cutting right now about 10 inches deep. He's also hydrating it as he goes through. So in this particular case, they're using Portland cement, so the hydration of that cement the flow of that will go smoothly. Here, he's doing some rough grading. So they've pulverized the roadway. So you're changing the cross slopes, putting in a super, taking out some of the bird baths, maybe even widening the road a slight bit. Once you've done the rough grade, you're going to introduce the Portland cement. Here it comes in bulk tankers. It's pumped onto spreader trucks. It's delivered at whatever the required rate may be, 40, 50, 60 pounds. Here they make several passes. Then the reclaimer will come back through and introduce the water and make its final pass to blend all of the cement with that lower grade material. So you're blending all that material together at 8, 10, 12 inches, whatever it may be, whatever the design is. Historically, that has been a challenge in the past, being able to monitor that water. With the technology we have today, we're able to monitor the water, the cement, and all of it in one pass. Water's critical, compaction's critical. Pad foot roller, the pad foot will come and give you your initial compaction rate. This is a 12-ton vibratory pad foot roller. You really want to get that density because now what you've added 40 or 50 pounds of Portland. You've added water to it, so you've increased that volume. You really need to get something to really get that compaction, so you got to have a pad foot roller and vibratory. Here, the pad foot's done its job. You've gotten your compaction. You received some of your compaction. He's doing some of the fine grading here. As he comes through, then you'll have the finish roller, which is a smooth drum roller. We're going to break some of this up into segments so we can talk about it. And the smooth drum roller really gives that finished look, gives you the ride you're looking for. The pad foot gives that initial densities 95, 98%. And during all this, obviously testing. So obviously nuke gauge is what we would use to use as a measuring tool to establish that rolling pattern, to find out where your densities are. And that's what we're doing here. So once the steel drum's gone through, it's made its final pass, we'll do some testing to find out whether we meet the requirements for density. In a lot of cases, in this particular case, VDOT employs chip seal as not a final surface, but a temporary surface for the traveling public. So it serves two purposes. One, it allows it to seal up that material, allows the material to hydrate below, and it also allows the traveling public to have something to ride on until it receives 2 or 3 inches of asphalt. You can see here, you've got the northbound lane is now almost complete. And once they've completed that section, they will immediately turn traffic onto that section and work on the other side. We're going to break this down just a little bit. We're going to talk about the pre-pulverization. In this operation you saw at the beginning of the video, this is critical, and this is where you get your value out of reclamation. You're able to take a secondary road or highway application or primaries, but secondaries are notorious for turtlebacked options, and it needs to be wide, and you have an 18-foot section, a 20-foot section, and you need consistency throughout that road. You need a 2% or maintain a 3% cross slope. You need to put a super in. Well, this is where you do that. And so now what you're doing through here, you're pulverizing that material. And the intent is now you have an opportunity to move that material the way you need to. A lot of times there are projects that contractors worked on, I've seen before, where they've actually taken the road and widened it 4 feet, or they've taken a road section and moved it around a utility, around a super. So you're able to take that material and use it on site. It doesn't have to be trucked. So it's very beneficial in that manner. Once you've done the pre-pulverization, and once you've now done some of the fine grading, you're going to roll into the application of Portland cement. This particular case, this piece of equipment will deliver the lime and or the Portland cement in this case. I believe earlier we spoke of delivering lime or cement or emulsion, the different additives. In this case, most of the times the studies have shown that we've been able to use Portland cement. So here the contractor is using cement, and in doing so you take a 3x3 tarp to make sure that you're delivering the 40 to 50 pounds. This is a critical reason you want to get what you're paying for. If we decided that you needed to get 45 pounds for this design, you want to make sure you're within that window of tolerance. So this is the way that's achieved. You take that, the spreader truck will ride over that section, deliver that material to that 3x3. And on the right-hand side, you can see, I should use my pointer here. On the right-hand side, there was a scale sitting there, and you'll see it as we come back by. The scales are there, the bucket's there, and so that material then can be weighed and verified and quantified. Make sure we're delivering within the tolerance. Once the cement has been spread, what you want to do is implement it with the machine. Now remember, historically what has happened is you've been able to hydrate the material from top to bottom. And when you cut 4, 5, 6, 8 inches deep, you're only hydrating that 3 or 4 top inches. So you're not getting the benefit for the cement that you purchased. Well, now the technology really allows us to hydrate through the head of that machine. So whatever depth the head of that machine is cutting, it could be 6, 8, 10, 12 inches, 15 inches. So you're getting the full benefit of that machine and the full benefit of the cement, because now you're hydrating that matrix all the way to the full depth. That's important because obviously the cement doesn't work if it's not wet. So, or lime for that matter. A lot of that material just needs to be hydrated. There's several ways to do it. This one is the primary way. We prefer to see this method. This is obviously through the pilot. You're seeing a view from the operator's perspective. And the reason, again, you can quantify all of that. You can quantify the water. You can quantify the amount that's being delivered to different sections. Some sections, as spoken of earlier, will take less, some will take more, and so we can quantify that through that machine. It's all being computerized, it's being verified through the head. And then when you get done, you hydrate the mat once you're complete. The intent with that is to maintain a hydrated surface so that you don't get any shrinkage cracking, particularly with cement and some of the other additives too. So you'll hydrate until you receive that chip seal. If you go on a job site, typically you don't want to see dust. If you have the traveling public is providing dust, now some of those days when it's 100 degrees and it's tough out there and it might get a little bit of dust from time to time, but you should be able to, in most cases, you should go out on the job site. It should appear as though the water truck has been there within about 15 or 20 minutes. Grading is absolutely critical. Grading, if you will, that is your ride. On a lot of applications, since you can use a variety of surfaces, you can use a surface treatment, you can use a very thin layer of asphalt, and obviously, if the grader operator is having a bad day, you're going to get a bad ride. So that is absolutely critical to have that person, that operator, trained properly, and they're able to deliver that rideability that the department is looking for. Compaction is absolutely critical. We spoke of it earlier. We really want a steel drum roller, 12 tons, a sheep foot initial pass to get your densities. You really want to achieve the 95 to 98%. Then you come back through with the steel drum. The steel drum will then provide that aesthetic look and that ride you're looking for. The curing methods. There are several ways to cure in this particular case. In some of the other additives too, whether you're using a lime or whether you're using an emulsion, you still have to apply moisture. You can use an asphalt emulsion, you can use a chip seal. That seems to be the preferred method that the department likes to use, is the chip seal. Moisture cure until it can receive that chip seal. And this is one of my favorites. Now bear with me for just a second so you can really understand it. And this is one of the reasons why we use this process, why the department has embraced it. It is a tremendous cost savings and it is a truly sustainable process. Here you're looking at, this is a 1 mile section of road, 24 feet wide, 2 lanes, 6 inches. 6 inches was removed, the 2 miles were done right beside each other. The reclamation side was done adjacent to the 1 mile section of a mill and fill of 6 inches. What they did is they compared all of that. Each project was overlaid with 2 inches of asphalt. Okay, so they removed the 6 inches, put 6 inches of material back, put 2 inches of asphalt on top of it. They did 6 inches of reclamation, put 2 inches of asphalt back on top of it. We prefer to see 8, 10, or 12, but in this particular case, they used 6. But even with the minimum amount of using 6, you still limited your trucks. The conventional method was 180 to 12 trucks with reclamation. All you're bringing is cement tankers. In this particular case, you hauled nothing off. In the conventional method, you're hauling a tremendous amount of material off. The tonnage is really being removed. Whereas very little is being removed, you have your spoils, if you will, from your grading operation that you have to remove. Nothing went to the landfill. Reclamation, you can see, lost a few tons to the landfill in this particular case. In a larger impact here, 3,000 gallons of diesel versus 500 gallons. Why is that? Obviously the trucks. I mean, you went down to 162 trucks, whatever it is. I mean, it's significant, 158 trucks. I mean, it's pretty significant when you talk about the diesel and the impact that you had between them, the ripple effect that you have on the adjacent infrastructure that you're rebuilding. You figure you're taking that many trucks off, you're taking 120, 130, 140 trucks off, the damage that's not being done to those other sections of roadway. The diesel that's not being burned, the traffic, the less traffic, it just adds up. It has a tremendous ripple effect. There's a tremendous value in what this process offers. Several layers, if you will. Changing gears a little bit, you've seen some of the open road. You've seen the video where you saw out in the country, out in the pretty cornfield, and the wind's blowing. And well, this also can be done in an area where it's a little bit tighter. That's a little bit more of a challenge. And you find yourself working in utilities, working in curb and gutter sections. It can all be done. It is a little bit more timely. You have to play, the contractor really needs to know what the expectation is. You have the utilities here. You can see where he's cutting in the corner. DI sitting right here. Curb and gutter left and right of him. It takes a little bit more time, but all that material is then pulled away from that curb line and pulled away from the utility. The reclaimer will come through and pulverize all that material and blend it all together, making it an homogeneous mix. That's the whole intent. And that material is then graded back and compacted properly. We're going to review this one more time. We're going to discuss this real quick. This was a project, I understand the contractor was working in Northern Virginia. Each home, as you can see here, along here there was a total of about 75 homes. Each one has a gas line coming from each one of them. So obviously there is a high opportunity for error. This process was employed here. It's a high pressure, either air or water, and the intent was, obviously you don't want to destroy it. And you'll see here in a few minutes, in a second or two, where you'll see that the actual piping is PVC. So with a pickaxe or a shovel, you can see that you could have damage. Plus the time that's taken. I mean, how many crews would it take to go down 14 inches and you have 75 homes to do this in? So it's a huge time-consuming, labor-intensive issue. So here the contractor employed this process and this equipment where they're able to punch through the asphalt, punch through the subgrade material, and deliver the pipe unscathed. So they mark it, they take that material, they take that material, they measure it, and you have markers on either side. So as that operator comes through, he knows where everything is. Whether it be a gas line or whether it be fiber optics nowadays, phone lines, it is an expensive and a life-threatening issue. And so these are extremely important to address. And this piece of equipment allows you to recycle everything on site. It's very similar to the reclaiming operation itself. All that material is then removed out of that hole, is then obviously returned right back to where it was, so you can use it on site. Nothing is hauled off. Each one of these holes took about 5 minutes. When the contractor used this for the first time, this was actually the second operation that they had with 75 homes. The time was allotted for a week's worth of work. He was done in a day. So it's really phenomenal how that process works. So to the contractor's benefit, to manpower benefit, and obviously to the homeowner's benefit, nothing was struck. Some of the candidate selections. These are ideas of where are you going to use reclamation. When you go out on the job site and say, why are we using this process? This is unusual. We're going really deep. Why are we going so deep? Don't really understand it. The cost, what's involved with it. Typically, you want to use distressed sections. These are sections of roadway that have lived its life. This section of roadway is about 40 years old. It's just lived its life. It's stripping a little bit from underneath. So it's time to rebuild. The section you see here is from a neighborhood, brand new, in the middle of construction. I know we've all seen this before. What happens, the heavy construction comes in, starts tearing up the base asphalt that's been laid with the heavy clays that we have here in Virginia. That's very typical. The contractor was trying to release this road right back to, the developer was trying to release it back to VDOT. Obviously, VDOT has concerns with this roadway. The developer chose to use reclamation to improve the situation here, and he was able to work through the construction time too. He was able to reclaim the road, continue construction without any further deterioration or cost to himself. This project is a little bit older road. It's up in the mountains. It's lived its life. You can see the alligatoring. Some of the issues that we run into too, we have a lot of trenching issues where we have new utilities. Utilities have been installed some time ago, and now you have that sagging, if you will, and it reflects back through the asphalt. This particular case, this is another new subdivision. They haven't even put the last layer of asphalt on top. And you can see where you're already losing some of the sections of road because it wasn't compacted properly. The reclamation process will allow a bridge over that section of roadway. Some of the other advantages of using this process is you can take out, the contractor was using a mill, took out 2 feet on either side, went from 20 feet wide to 24 feet wide. I believe this section of road was going to a military base, and so the understanding was they needed a little bit more width because there was high construction equipment that was going to be used on this roadway, plus you had tanks and had some other things that were coming in and out of there, so they wanted to widen the road. Well, what they did was they hogged out that material at 10 inches on the side, took that organic material away. You're going to put some ABC stone back. Instead of using the ABC stone, they end up using and employing the reclamation process. The benefit for them was about $1.5 million. So you have this section here that would typically be filled with stone is now backfilled with the reclaimed material from the roadway. There was plenty of material in the roadway to fall into the trench, and then he'll make this pre-pulverization, if you will. It was, we discussed earlier, we pulverized that roadway, and as the contractor came through, that material fell into the trench, and the contractor will go back and then incorporate that trench. So now you don't have that longitudinal joint. Everything is one homogeneous mix. This is kind of what it looks like before you even put a grader to it. You can see how it naturally falls right into the trench. It's like it's supposed to be there. It's back in its home. Here you can kind of see a final view. Went from 20 feet to 24 feet wide, put a little shoulder stone in the back. It's nice and clean. Some of the things that you'll find, the benefits of the reclamation process, as we close here, things to think about. Obviously, they're thinner pavement sections. Typically, if you're the strength of the reclamation has a very high structural value for what it is, and you're recycling. Now, it's not a typical CTA or CTB that we're all familiar with. It is a hybrid. You're blending asphalt, stone, and soils all together. So it acts differently, and we have to think of it differently. We want to put it in a special category of its own, because that's exactly what it is. Don't try to pin it to CTB or CTA. You can't. You really have to let it ride its own trail, because that's what this is. You're blending all those materials together. One of the other things, the in situ materials, back to that. Whether you're up in Blacksburg and you're dealing with very fat clays, or whether you're down at the beach dealing with a little bit more sands and even dead sands, if you're familiar with those, and everything in between. So this process blends all that material together, and that's why it's so critical actually to take some soil borings and take some samples so you can get a mixed design, so you can find out what's out there, so you know what material to apply, what additive to apply, and how much. It is quick construction. Typically, you can run about a quarter of a mile to a mile a day, depending on how the contractor set up. The contractor has multiple pieces of equipment staged, or have the lanes closure. Just all depends on what does the department want, how fast do they want to move. The contractor can typically deliver as long as the expectation is known. How fast do we really want to move? How fast do we want to get this recovered? The other section reduces moisture susceptibility. We did speak a lot about today about Portland cement in particular. We have some hydrostatic issues that are very particular to Virginia with the Chesapeake and Kilmarnock and a lot of the low-lying areas in the Chesapeake. We have hydrostatic issues where the asphalt will actually strip from underneath the roadway because of the ditches filling with water back and forth. This acts as a barrier and bridges over that material. Uniform distresses erosion. You're limiting that, and they go hand in hand. Where you're in an opportunity where you don't have at the beach. We've seen some issues where a hurricane will go through the beach, where we can limit that erosion. Certain sections of the roadway down in the Outer Banks, 12, have been reclaimed, and they've used materials where that material, the water washes off, the asphalt will be stripped off of the reclaimed material, and the reclaimed road is still sitting there because the currents were so strong. So it does really limit that erosion issue.